Hello everyone, it's March the 3rd. So I tried to set up the debugger for Java. I gave up. That thing is way too complicated. Well, mostly because I'm not really familiar with Java's whole tooling system, like how Java's supposed to work. I'm not really programming anything Java related. It's just I have some of the LeetCode I'm doing in Java, so that's why I'm trying to get a Java setup. But man, that's just a lot of effort to set up Java. While I do have IntelliJ already set up, so I can just use IntelliJ to debug whatever Java code I need. I can write it in NeoVim and I just copy and paste into IntelliJ. Now the main thing is for LeetCode, I just write it like I treat Java, the thing I wrote, as a script, right? And that's also how I want to debug. But in Java land, you need to have like a project and all that type of thing. You need to have all that type of thing. So I think it's pretty hard to get my current system to work in NeoVim. Like I need to create like specific projects, I guess, and then link all the stuff. Oh man, I look into it and I just gave up. And in the future, if I really need to, right? If I am, really have to get a Java setup, then I'll do it. I'll do it, but maybe I'll just use the NeoVim Java because there is one like that. So maybe I'll try that. And then, man, then you have to switch with like two different setup of NeoVim. That seems very stupid. So yeah, you know what? If I really need to Java, I will spend a day, spend a week. We'll get it done. But right now, I don't have any drive to really set up Java. Plus, I don't really want to code in Java. I really want to go for the next language. I think I'm not as I mean, Rust will take time, right? A lot of time. So maybe I'll go with Go. Just get that one done. I tried Go in the past, so maybe I can just do Go and use Go to solve the problems. Yeah, just kind of get away from Java. Yeah, I do not like Java. It's too hard to set up, or it's just like you have to use IntelliJ or whatever, those Eclipse, right? Everything is set up for you. All right, let's try this one. Oh yeah, and I thought about this yesterday, so we're timing out, and I'm gonna try Dijkstra today. Okay, I'm gonna try Dijkstra and see if Dijkstra works. If Dijkstra doesn't work, then hints. Okay, I don't know. I mean, I got stuck. All right, bag of tokens. You start with initial power and initial score and a bag of tokens given as an integer array tokens, where each token's I donates a value of token I. Okay. Your goal is to maximize the total score by strategically playing these tokens. In one move, you can play an unplayed token in one of the two ways, but not both for the same token, face up or face down. If you go face up, if your current power is at least token I, you may play token I, losing token I power and gaining one score. I kind of remember this problem. Yeah, so if you can take token I away, you can take that and then gain one score. If your current score is at least 1, you may play token, gaining token I power and then losing one score, and return the maximum possible score you can achieve after playing any number of tokens. So it is DP, as DP as it can get. So we just need to figure out how we transition the states. So we have a bunch of tokens, and then your start score is 0. So we can say DP definitely with a score, right? With a current score. And we also need damn it, maximum possible score you can achieve after playing any number of tokens. Huh. Is it really DP? So any number of tokens. So you start with power. Ask him if you want to hold a little baby. Do you want to hug the younger brother? Okay, so asking him to sit over there so he can hold the baby. So this is him holding the baby. And then he said, "No, I don't want to hold anymore."
He said that?
No, he just looked up and then he withdrew his hands. Okay, again. His hands are here and then withdrew his hands. That's it. I don't want to hug anymore.
A baby holding a baby.
A baby holding a baby, yeah. Very cute. Alright, where am I? I was watching some baby videos. Power. Score and power. Right? So given the current token, given the current score and the power, if we run that, then we will return the maximum possible. My dad just said, "Look at his facial expression." I think referring to this video, and I said, "Yeah, he looks like he doesn't know what to do." My father said, "Very funny," and he said, "Eric is very smart. Like today, the whole day, he's with just like sticking to my cousin." I think it's because the cousin is sticking with the baby, so he just sticking with the cousin to always taking a peek at the baby. A new human being that's even smarter than you, Eric. Okay, so we say DP score. Oh, hold a second. Why do you say DP score? That is bonkers. You don't say DP score. You want to have score. You don't put score in here. Come on. Get your stuff together. So it's just power, right? So given the current power and what? Right? Given the current power and because you want to know what is the maximum. And it can take any, right? It can take any. So maybe it is just DP power, right? So given the current power, it tell me what is the maximum score you can get. And with this power, I can do different tokens, right? I can take any tokens. And for each token, I can do two moves, okay? I can do 2 moves. So we can actually take a peek. But we have 10 to the 4th on the tokens. So I'm not quite sure. No, hold on. No, there's a token value. 1,000 on a token. Interesting. 1,000 on a token. But if you do the way you want, it's going to be 10 to the 4th times 1,000. I'm not sure. Okay, let's just read through some examples. So token is 100, power is 50. Because the current score is 0, you may play token gaining, so you cannot gain. And the current power is not at least, so it basically cannot do anything. Right? It cannot do anything. So if I have here, current score is 0, right? So the first step is always not face down because you don't have at least 1. You need to lose 1 score. So the first step is always try to see if there's any token whose power is smaller than your current one. Token is smaller, so I have this. So we place face up, we get 50, and then we have a 1. And you cannot play a face up to add to your score. Yeah, you cannot add to score. And if you play this, then you increase, right? It becomes 250. Then you go back to 0, right? And then you can decrease again, right? You can do any number of tokens. You want to put it face up, right? Because every time you face up, you are gaining score, right? You're gaining score. Okay, so you want to accumulate a lot of power. If you have a lot of power, you can keep playing the tokens, so you can gain score, right? And at a certain point, you will gain a score, right? You have a score, so you will gain power, but you will lose a score, right? You will lose, and then you can reduce your power, then gain score. You can reduce again, you can gain score, reduce. So you want to place face down fewer times than you place face up, right? So you want to play face down on the largest token, right? So you'll gain 1. So you will play a smallest token face up. That's the first step, right? No matter what, you have to play the smallest token face up in the first. So you gain a power, that you gain 1 score, and you reduce some of the power. And then you play the biggest token face down. So you reduce to 0, but your score goes up, right? And then you can do it again, right? You play the smallest, so you go down, and so you can do this to build your score up. And okay, so let's see. The requirement is every time you reduce, if you reduce power, like in here, you reduce 100 and you plus 200, right? So if you do this round, you will plus 100. So after 1 round, you'll become 250, right? So you can do it again. So you become 350. I don't know. Hold on. I got a little confused. Now you already. We should have beautiful, lovely dream and happy, wonderful sleep for tomorrow, feeling like wow, you are so much beautiful. Anxious with the food. This is all us. Now, every time I feel bored, I do the typing practice. Like if just if you're bored, like if I'm in a transition from one project to another, or for a moment I don't know what to do, so I just start typing. They walk out at the same time. All right, let's get back. I don't understand. Each token can play only once, right? maximize by 3 play these way. In one move you can play an unplay. Oh, unplay token. You can only play it once. Okay, you can only play it once. I was like, if you can keep playing, you can just keep going. Or you can only play it once. Okay, then in this case we have power. We will always minus 100 and a plus 400. Right? We do this, and then minus 200 plus. Okay, that's actually not true. So we'll do this round. We have to. So this is the first one we have to do, right? There's no question about it. We have to minus the smallest, right? So we will gain 1 power, and then we plus the biggest. So we need to build the power up. So now we have 500 on the power with 0 point, right? So in this case, I think it depends on how many I can get by doing the current power. So I do 1 round, right? I have to do 1 round, so I have the current, and then I check how many tokens, right? I can remove based on the current. I have 500, so I can remove 2. So that's that, and we can keep doing. Now we can keep going. And by keep going, we can say, you know, I minus 200 and plus 300. So we'll gain 100 more, which means in this case, I'll become 600, right? 600. And then we say how many I can get, right? So now the question is, every time we do this minus the smallest and the plus the biggest, then we get a new value. Can we get more, remove more power? How do I know that? How do I know how many tokens add up, like in the middle, add up to the current power, right? How do I know that? Well. So O(n) squared, right? We can always do O(n) squared. So you can go, actually, we can do like a sliding window, right? Because I just need to know how many add together is smaller or equal to the current power. So I know the starting index, right? And then, so at the beginning, I'll do this, and then I have the starting index, right? And I have not the end index, but yeah, just like the current. So we have a left or right. We have ij and I have a k. Okay, and then for k, I just keep moving, p and q. So p and q keep moving to the right until it gets bigger than the current power. So we check if it's bigger. If it's not bigger, so I just move forward until I have the current range, right? I know how many, and I will do the next round, right? I'll do the next round. Now, if the next round will definitely remove the current smallest, and then I need to update the range sum, and I keep moving forward, right? I keep moving forward and just try to see if we can get more, and if we cannot get more, then we get smaller, and then we try it again, right? Until at one time I remove the current range, right? I remove the current range, and then that's the end. Okay. Probably need to I feel need to be okay, so first things first, what I want to do is do arrays dot sort tokens, and then I have int I is 0, int j is tokens dot length -1, and int, no, these are the two. So we say while, so they just try to get to the middle, right? So while I is smaller than j, okay, while I is smaller than j, and power, right? Power. So we're gonna have int power. Oh, I have power, so I don't need power. So I just need score, right? Score is 0 to start with. So power, I can say power. Oh, okay. So also, if the token is only 1, right? If the token is only 1, ooh, edge case. Token is only 1, then you, yeah, if token is only 1, then you do, so token is 1. It depends, right? It depends on, okay, so so if the small, if, yeah, depends. If it's, right, so we'll get out. Because if I equal to j, we'll get out. And then basically that is the last one, right? That basically is the last one. And if we get out, if I is equal to j, then we, yeah, then we just check, right? We can say if we want to get out I is equal to j, then if I is equal to j, if I is equal to j, and token, ugh. If I is equal to j, tokens I is smaller than equal to, right? It's smaller equal to, at least, yeah, smaller equal to power, then score plus plus, right? And then we'll return score. So here is if the smallest power is larger, then there's nothing you can do, right? So we say if tokens I, if it's larger than power, then we can break, right? There's nothing we can do. We cannot do this anymore. Otherwise, we can always say power plus equal to tokens j, right, minus tokens I, right, and then score plus plus. No, score doesn't change because I removed the small and I added big, so it doesn't change. So now what we want to see is how many, right? How many we can get. Yeah, if token large, if token is smaller, then I will do this, and then the range sum, the sliding window, right? window sum. We have a window sum, and the window sum need to. Okay, so we need to have a window sum. Okay, so int window sum equal to not 0. Window sum equal to tokens 0. Okay, and int k is equal to 0. Right, so whenever we do this, how I'll do this, because I remove the smallest, so window sum into minus equal to tokens I, and then k. Oh, I need p and then q. My bad. Yeah, I need a p and q. So I have p is this, and q int q is also equal to 0. Right? So when this happens, we remove this, then p need to plus equal 1, right? So p will need to plus plus. Then p plus plus q shall equal to math maximum q or p, right? So now I have new pq, and the Windows sum is updated. Then we need to run with the current power, right? We say while q is smaller than, so we can say while q is smaller than while q is smaller than j, because q cannot hit j, right? Cannot hit j. Q cannot hit j. So while q is smaller than j, then we want to do while q plus 1 smaller than j, right? Yeah, while q plus 1 is smaller than j, so q plus 1 is smaller than j, then we can move q forward, right? And then actually q plus 1 is smaller than j, and window sum plus tokens q plus 1 is smaller or equal to power than q plus plus, right? So I keep going until we can now go. Now once we can now go, I get the current score, and the current score, I can say score shall equal to maximum actually score. So when we do this, score will be, you know, plus 1 minus 1, right? The score itself does not change, but in this case we'll get whatever score, yeah, will be whatever score we already have, and then we get this, and then we can gain that much more, right? We'll gain that much more, and yeah, the score can get bigger, right? And then we get a bigger score, and then if we keep going, wait, hold on, we score can get bigger, right? Because we count how many, and then that's the amount we can add to the current score, right? Or we don't do it this way, right? So score, we don't do it this way, and it'll be the original score, right? It will be the original score. So score, yeah, score shall equal to maximum, right? Math dot maximum score and p, q minus p plus 1, right? So that's the score, and once we hit this, right, so q is ending at this position, and once we hit this, and Now I'm gonna try the next one. So it can be I gonna plus plus, j minus minus, right? I plus plus and j minus minus. Now we try to run the same scheme. So we say I plus plus, j minus minus. And I think we should have another one of this, and j is larger than q, because if j hits the q, right, if j hits q, then what will happen if j hits q? Then you will only get smaller, so there's no point keep moving forward. So j has to be larger than q, so you have the potential to get bigger, right? You have the potential to get bigger. Yeah, so we keep doing this, and then window sum. Okay, maybe we can try this. Yeah, so basically we sorted. We have the left and the right. We have 2 pointers, and each time I take away the smallest and I add the biggest, right? I take away the smallest, add the biggest, and by doing so, the score does not change, right? There's no net change in the score, and after that, I get some power, right? I get some power. Then we need to compute how many remaining tokens can fit into this power. So that's the window, the sliding window. So we have the window sum minus the current one that's getting removed, right? Window sum minus that, and p plus plus, p is the token, the index for the start of the window, and q is going to be there, and then we're going to try q plus 1 if it's smaller than j, and if window sum plus this next token is smaller or equal to the current power, if that's the case, then q can move there, and I try it again. I try it until I cannot move forward. Either I'm going to hit j or I'm not, right? And then we can get, okay, it makes sense to me, but whether this will pass, that's a different story. Okay, I can just throw this in and then see if we get anything out of it. Okay, so these are correct. I'm not sure, but I can write some. Right, so we can say this is 948. So my idea is each round, right, we always remove the smallest token and add the biggest token, right? This operation does not change the score, but it accumulates the max power. Accumulates the max power for the moment, at the moment. Right, accumulates the max power at the moment. Then we check, okay, how many remaining tokens can fit in the current power. And we use a sliding window to check the tokens, right? To check the tokens in the middle. Check the tokens. So which give our total. I think that will be ON. Because everyone will be visited only once. Alright, let's see if this one's correct. Maybe it's not. Index out of range. Alright, that is. It says it can be 0? token length can be 0. So if it's 0, then just a 0. Okay, so we say if tokens dot length is equal to 0, then we'll return 0. Okay, are you happy with that? All right, let's see if this one's correct. No, it's not. Interesting. Okay. Okay, so this idea does not work. All right, let's take a look at this one. We have 31, 81, and 91, right? And we got 73. So the first definitely will remove this. We have to remove 31. How come it become 2? I remove 31, I plus 91, and I only have 1 left. Okay, that's a skill issue, right? So basically, these are all fine. And then I is 0. Okay, I is 31. Token I is larger than power. No. So it's a power plus equal to 60, right? Basically, power plus 60, so I have 133. And the window sum is 31, so I have minus 31, which is fine. So window sum currently is 0. And we are pointing at P and then Q, they're both pointing at 81. And oh, I think it didn't, damn it, my bad, I forgot to do window sum plus equal to tokens Q plus 1. I forgot to do that. Window sum to do that. And then, yeah, so it's always smaller than power. But still, it doesn't make much sense, right? It should be smaller. So Q, okay, Q moved to here, right? And then window sum becomes 81, right? And it's smaller than power. And then I try to go again. So the Q try to move forward. So Q try to move forward, and hold a second. P already moved forward. Then Q move forward as well, right? Q move forward as well. Then Q plus 1 does not smaller than J. So actually I didn't even do this. I immediately do this, right? I immediately do this. But that is not correct, because it has to be the current is smaller than, right? If the current is bigger, then I cannot even do that. So, ooh, that is interesting. Okie dokie. So P plus plus and then Q is this, right? And we check on the Q, and then we try to add the current Q. So it shall be if Q is smaller, right? Because Q, I move the Q to its current location. And the Q, oh yeah, the Q, I want the Q to be in the same position as before. So then I can, so I don't do this. Okay, I don't do this. This will move the P, this will move Q forward. Okay, so P will do this, and then Q plus 1, right? Now Q plus 1 is smaller, then I can do that. And then we try it again, then fail. Then score equals 1, I plus 1, J minus minus, right? Then when we get out, now see, that is the problem. When we get out, or we can just modify tokens, just to make sure, right? We can modify tokens. When the token is taken, I just set it to, a negative value, right? Or we can set it to 0. It's just fine, because a token can be 0, so I can set a token to negative value. And then at the end, when it gets out, if I is equal to j, right? So they meet in the same one, and we'll check, right? We'll check. Because we've taken those two, right? If we've taken those two, if I take the middle, it'll become this. Otherwise, I say, okay, I don't take, then I do that, right? Then I do, so the score, it's not score plus plus, it's whatever the previous score, because like if you don't do the middle part, the score will always be 0. If you do the middle part, you get some, you get some, you get some. So at the end, this shall actually be score, right? So equal to maximum math, okay, math.max score and 1. So this will give you 1 score, right? This will give you 1 score. This will give you 1 score. Oh. A lot of issues. Lots of issues. First one we have trouble. The first one is fine. The second one we have trouble. Okay. How? So we have 100 and 200, right? And then I do one operation. Oh yeah, I do one operation that I cannot. Holy crap. If I do one operation, I take 100. Then why do I do the 200? Right? Why do I do the 200? So basically it's token, so this I can definitely guarantee the score with math, right, dot max score and 1, right? So this I say just take token I, right? Just take token I of, well, get 1, and then we do that, then the score becomes 0, right? And then we do whatever the Windows stuff we do, and at the end, yeah. Okay, so if I run this, okay, I still have issues with this. That's interesting. Okay, I do this, so I have 500, right? I have 500. And then P plus plus, so P is pointing to this. Q is still at 0, right? And I say Q plus 1 is smaller than J, yes. Then Windows sum plus this is smaller or equal to power, yes. So Q move here. Windows sum become 200. Right, next one, Q plus 1 is smaller than J, because J is here, so that's true. It's good, so Q move here, okay. And then Windows sum go. And then next one, oh, get out. The score shall be Q minus P plus 1 shall be 2, right? Okay, why is this not 2? All right, take a peek here. System dot out dot print line. We're gonna print out. What are you gonna print out? Well, we can print out Windows sum Q. Okay, we'll print out Q. System dot out dot print line. We can also do token. Nah, let's do Windows sum. Windows sum. Okay, let's put these at the bottom. Okay, let's run this. Let's take a peek. I have a 1, 0, 1. And the Windows sum is, that is bonkers. Windows sum should be 200. Why Windows sum is 300? That does not make any sense. How'd you get to 300? I don't know. So put it here. Windows sum is 0. All right. At this point, we might as well just debug this. Yeah, there's just no point to keep struggling with this. So we're gonna go IntelliJ. And let's just debug this. We'll put this one here, and then we're gonna have tokens, right? So tokens, we're gonna have 100, 200, 300, and 400. More than that, we're gonna have power. Power is gonna be 100 and no 200. And then on here, there's gonna be bag of tokens. We're gonna do tokens and power. Then we need to set a breakpoint. Let's just put a breakpoint here. And where's the debugging? Debug here, debug. Okay, so it's cool, and there's a step over, step into, step out. So we step over. J is 3, 0 to 3. This doesn't do. So score shall be 1. Yeah. And power now is 500. That's good. And Windows sum is 0. That's good. P plus plus, P equal to 1. That's good. And then Q is 0. So this is true. Both true. So Q plus plus. Oh, Q plus plus. I see the problem. This. Oh, we might as well just do this, right? Yeah, we might as well just do this. I need plus plus, but I can do this. And this will be right. Okay, let's put all the test case back. All right, let's try this. Does it work? Ugh. All right, that's okay. Let's keep debugging this. What's the problem now? Output 1, expected 2. Oof. We have 26, 48, 87, and we have 81. Okay. But the score is 0. Oh, I can take as much as I want to begin with. Dude. So maybe I should do the sliding window first, right? I do the sliding window first to see how it fits the current power, right? How it fits the current power. So I do a sliding window to get the current, right? It's good, right? We do a sliding window for the current. And once we're done, we will do the removal. Okay, we do the removal. And for the next, we have the new power. We try it again. And then we do the removal. So basically, my point is we will start with this as a -1. And we do this one first. Okay, we do this one first. Okay, we do this one first. And we say the window sum will start with 0, right? So we'll take the sliding window sum first. Okay, once it gets out, I do this, which is, good, right? Which is good. And once this is done, I will check, right? I will check because I basically just say, okay, with the current power and my current P and Q, can I how much of the tokens I can fit? Once I'm done, I don't think about it again. I do the token thing, right? And if the token is good, I will. Then I don't need this because this one already considered. Then I'll do the power, right? I'll do the power. And when the power is done, right? When the power is done, then I do think I need to reset the P, right? I need to reset the P. Reset the window sum as well, because the window sum is from the start, right, going out, and then I take I and j out, right? I and j is taken out, so window sum need to do that, and the P need to plus plus, that is correct. Then we have to I also plus plus, j also minus minus minus, right? Okay, now the next round coming up, P, which is fine, and then we try to extend on the Q again, right? We try to extend on the Q again. And if I cannot extend, then just cannot extend. And then we'll do this thing again. Okay, let's see if I put this one in the test case. Do we have a good result? We have out of bound. Out of bound? That is, interesting. How would this be out of bound? How? I don't know. I know, because it has to be plus plus q instead of q plus plus. We need to do this because it will be -1. You need to increment it first. Okay, so we have some error again. That's the first one. What happened in the first one? This one, 100, 200 with 200. Honestly, I don't know. Hold on. Let me do this, and then do this, and then don't do this. I mean, check on the others. Okay, is that the only one we got wrong? Yeah. So this one we are wrong again. My return is 1. It's supposed to be 2. Interesting. So in the start, right? All right, don't guess. We have the debugger. Keep the debugger working, man. keep it working and end this, and let's update this, and I will put, okay, debug again. All right, power is 200, so now we're gonna, is that F8, okay, so we'll step in. That is good because I am currently at 100, so Windows sum will become 100, yes, and then the next one will get out. So now P and Q both are 0, so the score is 1. That's good. Token I is 100, is not, so we can do this. So power will go up. Windows sum minus, so Windows sum becomes 0 again. Right? Okay, P plus plus, P become this is 1, J. Okay, perfect. Now I is 1, J is 2. And but we first test, so the power now is 500, right? Power is 500, and P is 1, Q is 0. So again, Windows sum is 0. So Windows sum first, we're gonna accumulate 200. Okay, and then ooh, Q plus 1 smaller than J. Oh, I see. It should be smaller equal to J. Right? It should be smaller equal to J because at this time J, we haven't taken it yet. Okay, we haven't taken it yet, so it should be smaller equal to J. All right, let's run this. Are you correct? Oh yeah, now we got it. Way too much effort to get this one done. I feel like there gotta be an easier solution, right? There gotta be an easier solution. This is way too complicated. Plus, man, I'm still struggling with all the new. I'm still trying to get a new muscle memory for typing, and it's not really working very well. Like again, like on my right hand, there's a lot of relearning to do, and this was slow. Right, it's really slow. So I was wondering what the correct answer should be. Let's see. Increase score. Well, left is smaller than right. If token right plus P, what is P? P is power, right? P is power. And we say if tokens right plus P is larger than tokens left. Okay, so this one basically, so we try to get as much score as we can initially, right? And then we say if the token right plus this is larger or equal to tokens left. So we'll do that. We will increase score again, right? We'll increase score again because in this case, I can take off, right? Basically, I say I'll take tokens right plus P is larger than tokens left. Basically, I say I'll take away one score and I'll gain more power. And then I will, given this situation, how much more I can get. So I'll increase score. So I have tokens, left, right minus 1, yes. p plus this, yes, scores this, and then we just, you know, keep trying. That makes sense. And maybe my solution is not ON. I feel like it is ON. It's just a lot of... Okay, so I know what this one is. Let's take a look at... We always want to play the smallest token first, because that leaves us more token in the tank to attempt a larger one. We always want to exhaust our power by playing smaller tokens up before resorting to get more tokens. It's because if we go for the bigger token, but the end result is the same. When going for the bigger token, we always go for the max available. With these 4 points out, it's not complex. Play token face up to gain score. We do that first to get the most out of and we check whether it is necessary to take the current max token. The check is to add a max to current power. And it's a good decision to take the current because we have more chance taking face up. Yeah, so it's the same idea, but I guess it has a better implementation, which we'll try. Okay, there's no point not to try. Okay, so let's just go to 36. All right, so we need to also say this one runs really slow. All right, this one runs really, for whatever reason, it runs slow. But I still feel it is ON. Right. So this solution, so this is from my previous solution, okay, which is exactly the same, right? Idea as today, but with better implementation. I do believe it is a better implementation. Okay. I think I'm missing some stuff. Oh, I guess I need to do this. There we go. That's fine, right? And we need to write a function, yeah. So we say say private int face up. Okay, face up, I need tokens, right? Tokens, I need int I, int j, and int power, int score, right? I need all of these. Okay, so basically we're given the current power, current score. I need to move from I forward. Then we just say while I is smaller than j, and and power plus, no, not power plus power is larger or equal to tokens I, right? Once this is good, then score plus plus, right? Score plus plus power minus equal to tokens I plus plus, right? So we keep doing. Once we cannot, then we will return, right? Or return new int. Okay, return new int. We need I, j, current power, and a score. right? We need this. We'll sort it, and then we say int score, int return shall equal to face up. We always place face up first. The tokens. Okay, so we have tokens. I do need to put these one here. Right, tokens, ij, power, score. What is score? Score is here. Score has to go here. Right. And then, oh my god, this is not friendly. Oh yeah, we might as well just, yeah, we might as well int tokens, and we, instead of separate them, and then just say, int, what do I say? Elements, right? And then I can say int I is equal to element 0. Int j is element 1. Okay, int power is element 2, and int score is element 3. Then I don't need to return anything for this one, right? I can just call it a void, and at the end, instead of returning this, I just say element 0 equal to I, element 1. I mean, j will not change, so I just do element 2 will equal to power, element 3 equal to score, right? So here I just do int element equal to new int, or do 0 tokens dot length -1, and power is the current power, right? We'll do power and score. Then we don't need any of this. Then what we do is call face up tokens and element, right? And then based on if we have any score, right? Based on if we have any score. If no score, then yeah, this is nothing we can do. We say if element 3 is score is equal to 0, right? The first round is bad, so we just return 0. We cannot do anything. Otherwise, we can keep going, right? We can say element 0 is smaller than element this. Then what we're trying to say is if the current power, right? So basically after this, we have the current power. And we just, yeah. And then the current power, I can always, I have a score, so I can always place, do a face down, right? So while this, and then we do a face down, if it's larger than this, and I is smaller than j, right? I has to smaller than j. So we can say while element 0 smaller than element j, and power plus element j, because this is we're going to increase its power, is larger or equal to element, it's not this, it's not j, damn it, 1. All right, so this shall be tokens, right? Tokens element 1 larger than tokens element 0. When this is possible, it is necessary that we go through the thing again. So we call face up, and we'll do tokens, and then we'll do, actually that's when we change some stuff. So first thing we change is element, the power needs to change, because I'm going to add this power, right? I'm going to add this power, and the 1, right? This has to minus minus. Element power is 2, right? Element power. So this is actually not power. We have to go element 2. So element 2 we need to plus equal to tokens element 1, right? So we do this first. Okay, we do this first. Power, so we get a higher power. Okay, get more power. And then yeah, we get more power, and then we use this, then we go into this, right? So this one we'll do again, change in place everything. Once we change, we get out, we do this, blah blah blah. Once we're done, then we can just call it, right? So we go back to this, we can say D17, and then when we return, the score is going to be element score is 3. So that's kind of how this one might work. I'm not quite sure though. Okay, let's take a look. This one work? This one works. This one does not work. So we need to do smaller equal to j, right? I have to do smaller equal to j. How about here? I think this is smaller because I need to take that and I need to compare to the front. Try that. Jesus. Yeah, how do you handle this? So maybe I do this small equal to as well. I don't know, just play with it. Nope. That ain't right. Too much. Too much. Interesting. I mean, smaller makes more sense. Does it make more sense? Because I'm taking away, right? I'm taking away, and then up to j. Yeah, I shall be able to. So I think this makes sense. This does not make sense, but it's still wrong. Right? It's still wrong. Same problem. Right? Same problem. This one, the same problem. Okay, so we start with 200, right? And then I take Okay, so I sorted and I got the indices. I want to see in this range, given me this power, and then we do face up. So while I smaller than j, so then I plus plus, and then add score and power minus whatever I have. Then I do it again. I smaller equal to j, right? And then it's true, but then power larger equal to token size, that's false. Because power minus 100 becomes 100. So, okay, so that's not good. So when it's not good, I stop at 1, right? I stop at the 1 that we cannot take. Okay, we get a power, get a score. But we have a score. Again, now we say this is smaller than this, yes, and element 2 is the power plus tokens, element 1. Which in this case, 100 plus 400 will be 500, right? It'll be 500. And oh, I see. It didn't change the score. Because if you do this, you have to change the score. Element 3 need to minus minus. Right? So this is get more power. Can use jth token. Right? And here is the cost or to score by using the jth token, right? So because you use this token, so you have to incur this cost. So now the score decrease. Then we run it again. Okay. So do I do the equal sign here? I don't, because if I do the equal sign for these, if I and j is the same, then I cannot do this because you can only do it once, right? So if we run this, then it's right. Okay, let's try it again. And in fact, if I don't even need to index I, j, power, and score, right? So now I don't need to do all that. Right, let me just use element 0. This is element 1. This element 2. This is a token element 0. Right, and then score is element 3. Power is element 2 minus equal to token element 0 plus plus. That don't need to do all that. Run again. Okay, try it. Interesting. It's even slower. But yeah, that's that. All right, anyway, I feel like I am severely restricted because right now I'm handling this typing thing, so my mind is always going through two different places, right? I'm always going through two different places. It's not really what I want. This is 2 point. That's very simple. O and log n. That's not O n. I forgot. My bad. It is O and log n. Shoot. There's a sorting involved. Okay, let's take a look at this implementation. There's a 2 pointers. I have a low and a high score we sort. Well, low, slow, and high. If power is larger than the low, I do this. Power, do that, low plus. Perfect. And then we do it again. If power, then we do it again. Until we can't, then we check if low is smaller than high. If that is, and then we have score, we do score. Power, do this, high minus. And then, yeah, wow, it's so much better. I think it's deserve a solution number 3. My God. Okay, let's I think it's deserve a little bit more love for this. First of all, we don't need this, and this is the official solution, right? So I'll say this is from the official solution. Hey. So sort int I 0 int j is tokens dot length -1 in score. Okay, and then we can remove all of the others. So 23k, then D11J. Oh shoot, D11J. There we go. Okay, so we can say while I is smaller or equal to j. Okay. Then we say if power is larger or equal to tokens I. Alright, if that's the case, then score plus plus power minus equal to tokens I and I plus plus. Right? We do that. Else if I is smaller than j and power and score is larger than 0. This is the one we're going to sacrifice. Then we say power plus equal to tokens j, right? And score minus minus. Right, so this basically we say this this is face up. Right, and then this is face down. Right, and then else, then nothing we can do, so else will be break. And then when we've done all that, we just return score. Okay, 24. Ugh. Right, let's try this one. This is the real one. This is the real solution. Oh my God. What? What? All right, what did I do wrong? Oh, I forgot move J. My bad. My bad. I forgot to move things forward. Yep, I forgot it's J minus minus. Yeah, that's my bad. J need to move forward. There we go. Oh, that was right. That is the correct solution. My goodness. Alright, I didn't realize this one spent so much time. Yeah, I spent so much time to do this. I got stuck, honestly, like at the beginning. Wasn't realizing that this is you know, this is brain teaser, right? It's a greedy problem. I thought I just DP this, but it turns out you can't. I got a bunch of wrong answers initially. All right, that will be it. I'll see you guys tomorrow. Adios.